Hello. So today I want to talk about the three different types of inference procedures that we've learned so far. And I want you to understand the differences between them so that when you look at a problem, you know which procedure to use. So far we've learned three procedures. The first procedure is the sampling distribution of sample proportions. So basically what this means is that we're comparing an observed proportion, which means we're dealing with qualitative data, and we're comparing an observed proportion to all the other possible sample proportions that are possible. That would be the sampling distribution. Now, in this case, we know the parameter, which means that we know the true value of whatever it is that we're looking at. Another possibility that we've talked about is similar. It's a sampling distribution of sample means. So the difference between this procedure and the previous procedure is that here the data is quantitative. And so we're comparing a sample mean, not a sample proportion, to all the other possible sample means. So here the data is quantitative, and here again the parameter is known. So in these two cases, when we're dealing with sampling distributions, we already know the true mean and the true standard deviation of the population. Now, many times we deal with situations where the parameter is not known. In this case, so far we've learned the one sample z interval. Now, the one sample z interval is a confidence interval, which is an interval of plausible values for an unknown parameter, in this case, an unknown population proportion. So the data is qualitative, but the key difference is that the parameter is unknown. So now let's look at some questions that we've talked about to see which procedure do we use. Now, let's read this question carefully. Take a minute and look at this question. Which kind of procedure are we using? Well, we see here that we suppose that 70% of college women have been on a diet within the last 12 months. This assumes that the true value of the population parameter is 70%. And so in this case, what we're going to do is we're going to construct a sampling distribution. And so we're going to look at the sampling distribution of sample proportions. So if you look at the calculations here, we see that our standard deviation formula is the square root of p times 1 minus p over n. That's 0.7, the true value, times 1 minus p, which is 0.3, divided by n, which is 267. And you notice here that we have the square root of p times 1 minus p over n. We don't say p hat because we know the true value of p. And so in this case, we do a sampling distribution of sample proportions. Now let's look at this question. What kind of scenario is this? In this case, we are looking at quantitative data, not qualitative data. We're not dealing with a sample proportion. We're dealing with a sample mean. So in this case, because it's quantitative data, we're going to be constructing a sampling distribution of sample means. And so here we see that the standard deviation is going to be sigma over the square root of n. Sigma is the true standard deviation for the entire population, which we know is 35 from the given information. And the sample size here is 50. And so here we use that information to construct a normal distribution, and we use that normal distribution to evaluate the likelihood of, in this case, a random sample of 50 students having a total of more than 2,500 texts in one day. Now let's look at this scenario. Here, we're not given any true value for the parameter. We're only given a value of an observed value, which in this case is our best estimate of the parameter. Since we don't know the true value, we cannot construct a sampling distribution of sample proportions because we don't know the true value p. So in this case, we're going to construct an interval of plausible values that's centered on our best estimate of the truth. Our best estimate of the truth is the 18 over 225, which is our p hat. That is our observed proportion. So here you see that we're building a confidence interval to estimate P, the proportion of machine parts that are damaged in shipment. And so here you notice that when we calculate the confidence interval, if you look at the formula down here, we see that the formula for the standard error, not the standard deviation, because we don't know the true standard deviation. The standard error is the square root of not p, but p hat, because again, we don't know the true value of p. So it's p hat times 1 minus p hat over n. We take the square root of that, and that's how we get the standard error, which we then use to construct the margin of error, which we then use to construct the confidence interval. So make sure you understand the difference between when we use sampling distributions and when we use confidence intervals, and make sure you know the difference between whether we are dealing with qualitative data, in which case we'd use sample proportions, and when we have quantitative data, in which case we are dealing with sample means. And remember, there are two different formulas. The square root of p times 1 minus p over n is the sampling distribution formula for sample proportions. Sigma over square root of n is the formula for the standard deviation of sample means. Those formulas are given to you on the formula sheet, but you have to know when to use them and why.